We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Okay, my feet are out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 107 of the Space Rocket History Podcast. And now, the Mode Decision, Part 2. Recapping from episode 106, I covered the four main modes for landing on the Moon: direct ascent, Earth orbit rendezvous, lunar orbit rendezvous, and lunar surface rendezvous. I also covered other modes that were not selected. A decision on which mode to use has not been reached yet, but as the analysis continues, lunar orbit rendezvous seems to be moving ahead. Most of the early criticism of the lunar rendezvous mode stemmed from a concern for overall mission safety. In the minds of many, rendezvous, finding and docking with a target, would be a difficult task even in the vicinity of Earth. This concern was the underlying reason for the trend toward larger and larger Saturns, such as the C2 through the C5, to lessen the number of maneuvers required. After all, von Braun had once suggested that as many as 15 launchings of the smaller launch vehicles might be needed for one mission using Earth orbit rendezvous mode. But Earth orbit rendezvous had an important advantage. During rendezvous operations, the crew could return to the Earth if they failed to meet their target vehicle or had other problems. In lunar orbit, where the crew would be days away from home, a missed rendezvous meant death for the astronauts and raised the possibility of an orbital coffin circling the Moon, perhaps forever. And all this talk about rendezvous came at a time when NASA had only a modicum of space flight experience of any kind. It is not surprising, therefore, that Hobart had trouble convincing others to choose lunar orbit rendezvous. Fears for crew safety and lack of experience were not the only factors. The Langley lunar orbit rendezvous approach was criticized for another reason. One of the principal attractions of Hobart's lunar orbit rendezvous mode was the weight reduction it promised. But Hobart and his colleagues, in trying to sell the mode, had oversold this aspect. Many who listened to Langley's team proposals simply did not believe the weight figures cited, especially that given for the lunar landing vehicle. In the lunar mission study at Vought Astronomics, Dolan and his team had given much thought to designing the hardware, including a landing vehicle. Their weight calculations for a two-man lunar landing module were much higher than those proposed by Langley engineers. Vaught's study projected a 12,000 kilogram vehicle, most of which was fuel. Empty, the lander would weigh only 1,300 kilograms. But until late 1961, no one in NASA, except Langley, had really looked very hard at lunar landing vehicles. Using theoretical analysis and simulations, the rendezvous team at the Virginia Center had studied hardware, software, flight trajectories, landing and takeoff maneuvers, and spacecraft systems. The studies formed a solid foundation for technical design concepts for a landing craft. In fact, Langley's brochure for the Golovin Committee described landers of varied sizes and payload capabilities. There were illustrations and data on a very small vehicle able to carry one man for 2 to 4 hours on the moon, an economy model, 2 men and 24-hour stay time, and a plush module, 2 men for a 7-day visit. Weight estimates for the 3 crafts without fuel were 580, 1,010, and 1,790 kilograms respectively. Arthur Vogley pictured the very small version as a solo astronaut perched atop an open rocket platform with landing legs. The same sort of minimal design features extended to subsystems, and structural weight further reflected Langley's drive towards simplicity. In February of 1961, at NASA's Inter-Center Rendezvous Conference, Lindsay, Lena, and Vogley had described the most rudimentary navigation and guidance equipment: a plumb bob, an optical sight, and a clock. This 3-component system was feasible, they said, only because maximum advantage is taken of the human pilot's capabilities. Even some of those on Langley's team criticized this kind of thinking. John Eggleston, for one, labeled it as impractical. Despite Hobart's frustration, his hard work had stimulated interest outside Langley. Within the Office of Manned Spaceflight, George Low, director of spacecraft and flight missions, commented that lunar orbit rendezvous may be the best approach yet, and Hobart had finally struck a responsive chord when giving his sales talk to the Space Task Group in August. At this briefing, James Chamberlain, Chief of Engineering, had been very attentive and requested copies of the Langley documents. All during the year, Chamberlain and his team had been working on a study of putting 2 men in space in an enlarged Mercury capsule. By the way, that enlarged Mercury capsule eventually became Gemini. Although this successor to Mercury had been conceived as Earth orbital and long duration, Chamberlain thought it might fly to the moon as well. Siemens recalled that Chamberlain was trying to develop something that was almost competitive with the Apollo itself. Chamberlain and several of his colleagues proposed using the 2-man craft and lunar rendezvous in conjunction with a 1-man lunar lander, which in many respects resembled the small vehicle studied by Langley. Although Chamberlain could only get approval for the Earth orbital part of his plan, one of the principal objectives, rendezvous, was highly significant. It marked the beginning of the first important shift in the Apollo mode. Gilruth and his engineers began to perceive advantages that had not previously been appreciated. Growing interest in lunar orbit rendezvous stemmed partially from disenchantment with direct flight. The Space Task Group had become increasingly apprehensive about landing on the moon in one piece and with enough fuel left to get back to Earth. The command section it had under contract was designed as an Earth orbital, circumlunar, and reentry vehicle. It could not fly down to the surface of the moon. Lunar rendezvous, which called for a separate craft designed for landing, became more appealing. Gilruth's engineers had worked on several designs for a braking rocket for lunar descent. In a working paper released in April of '61, Apollo planners had tried to size a propulsion system for landing, even though no booster had yet been chosen to get it to the moon. 2 methods for landing were explored. The first was to back the vehicle in vertically, using rockets to slow, then stop the spacecraft, setting it down on its deployed legs. The second technique was to fly the spacecraft in horizontally, like an aircraft. In this case, the legs would be deployed from the side of the spacecraft instead of the bottom. In the summer of 1961, when the command module contract was being advertised, Max Faget described some of the problems he anticipated with the landing. All other phases of the mission could be analyzed with a fair degree of certainty, he said, but the actual touchdown could not, since there was no real information on the lunar surface. Exhaust from rocket engines on loose rocks and dust might damage the spacecraft, interfere with radar, and obstruct the pilot's vision. Faget said the final hovering and landing maneuvers must be controlled by the crew to ensure landing on the most desirable spot. The Apollo development plan, in its many revisions, merely said that the lunar landing module would be used for braking, hovering, and touchdown, as well as a base for launching the command ship from the moon. About the time of the command module contract being awarded, Abe Silverstein left NASA headquarters to become director of Lewis Research Center. Silverstein believed that Apollo would probably use one rendezvous scheme or another, and he was among the staunchest advocates of big booster power and direct flight. Concurrently with Silverstein's return to Cleveland, Lewis was assigned to develop the lunar landing stage. Gilruth and Faget did not like the division of labor, as it added a complex management setup to the technical difficulties of matching spacecraft and landing stage. Faget proposed a different propulsion module from one previously envisioned for the descent to the lunar surface. He suggested taking the legs off the landing module and making it into a braking stage, which he called a lunar crasher. Once this stage had eased the spacecraft down near the surface, it would be discarded to crash elsewhere before the Apollo touched down. The Apollo spacecraft would then consist of the command center and the two propulsion modules, one to complete the landing and the other to boost the command module from the surface. Since the crasher's only job was to slow the spacecraft, it was not part of the vehicle's integral systems, which decreased the technical interfaces required and minimized Lewis's role in the hardware portion of Apollo. Faget based his proposal on some sound technical reasoning. The crasher engines would be pressure-fed, no pumps would be needed, and the vehicle would be controlled by turning the engines off and on as long as propellant lasted. Pump-fed engines, on the other hand, depended on complex interactions to vary the thrust. Faget and Gilruth liked the pressure-fed system, and so did Silverstein. Although relations with Lewis were easier after the adoption of the crasher, the Houston engineers were still worried about the complexities of an actual landing. As Faget later said, quote, "We had all sorts of little ideas about hanging porches on the command module and periscopes and TVs and other things, but the business of eyeballing that thing down to the moon didn't really have a satisfactory answer. The best thing about the lunar rendezvous concept was that it allowed us to build a separate vehicle for landing," end quote. Caldwell Johnson, one of the chief contributors to the Apollo command module design, had much the same reaction. He said, quote, "We continued to pursue the landing with a big propulsion module and the whole command and service module for a long time, until it finally became apparent that this would not work," end quote. By the end of 1961, the newly named Manned Spacecraft Center had virtually swung over to the lunar orbit rendezvous idea. But Gilruth, Faget, and the other Apollo planners conceded that this approach had drawbacks. First, it required a successful rendezvous with the command module after the lunar module left the moon's surface. And second, only 2 of the 3 crew members would be able to land on the moon. But the stage had been set for an intensive campaign to sell the von Braun team on this mode. At headquarters, Director of Manned Spaceflight Holmes wanted the two manned spaceflight centers to agree on a single mode. He did not expect to get this consensus easily. At the beginning of 1962, Holmes was not sure how he would vote on the lunar landing technique. Von Braun, among others, had made it clear that direct ascent requiring the development of a huge NOVA vehicle was too much to ask for within the decade. However, both Earth and lunar orbit rendezvous appeared equally feasible for accomplishing the moon mission within cost and schedule constraints. The decision, Holmes knew, would require weighing many technological factors. After directing Joseph Shea, his deputy for systems, to review the issue and recommend the best approach, Holmes laid down a second and broader objective. Shea was to use the task to draw Huntsville and Houston together, building a more unified organization with greater internal strength and cooperation. In mid-January 1962, Shea visited both the manned spacecraft and the Marshall Space Flight Centers. He found Houston officials enthusiastic about lunar orbit rendezvous, but believed they did not fully understand all the problems. He reported their low weight estimates as unduly optimistic. Marshall, on the other hand, still favored Earth orbit rendezvous, but Shea did not think the Huntsville team had really studied lunar orbit rendezvous thoroughly enough to make a decision either way. From these brief trips, Shea recognized the depths of the technical disagreement between the two centers. He decided to bring the two factions together and make them listen to each other. During the next few months, Shea held a series of meetings at headquarters attended by representatives from all the centers working on manned space flight. At these briefings, the advocates presented details of their chosen modes to a captive audience. The first of these gatherings, featuring Earth orbit rendezvous, was held in February of 1962. Headquarters may not have realized it, but the sense of urgency surrounding the mode question was shared by the field. Recognizing that the need for choosing a mission approach was crucial, Gilruth's men hastened to strengthen their technical brief. The Houston Center notified headquarters in January that it was going to award study contracts on two methods of landing on the moon, with either the entire spacecraft or a separate module, hoping one of the contractors would do a good enough job to be chosen as a sole source for a development contract. But Washington moved before the center could act. Holmes and Shea had decided that lunar rendezvous needed further investigation. A contract supervised by headquarters would tend to be more objective than one monitored by the field. A request for proposals was drawn up and issued at the end of January, and a bidders conference was held on February 2nd in Washington. Although this contract was small, it was critical, and representatives from a dozen aerospace companies attended the conference. Those intending to bid were only given 2 weeks to respond. Shea and his staff, with the help of John Hobolt, reevaluated the proposals and announced on March 1st that Chance Voigt had been selected. Chance Voigt's study ran for 3 months and was significant mainly because of its weight estimates. Houston calculated that the target weight of the lunar landing module would be 9,000 kilograms, but Chance Voigt came up with a more realistic figure of 13,600 kilograms. Shea and his team, in subsequent mode comparisons, used Charles Voigt's higher weight projections. Holmes' Management Council was also studying the mission approach. On February 6, with Associate Administrator Siemens present, the group heard another of Hobolt's briefings on lunar versus Earth orbit rendezvous. Charles Matthews, Chief of Spacecraft Research Division, then described Houston's study of the lunar rendezvous mode. Von Braun interjected that selection of any rendezvous method at that time was premature. On March 27th, the Council discussed the Chance-Voigt study. Several of the members were concerned about the weight the contractor was estimating the Saturn C-5 would have to lift, compared with that projected by the Houston Center, 38,500 kilograms against 34,000 kilograms. This disparity was very serious, since Chance-Voigt's work would be useless if Marshall decided that the C-5 could not manage the heavier load. The Council also noted that the mode issue was beginning to affect other elements of the program adversely. North American was designing the service module to accommodate either form of rendezvous, but as more detail was incorporated into the design, being able to go both ways would cost more in weight and complexity. On April 2nd, Shea called Field Center officials to a meeting on lunar orbit rendezvous. After some basic ground rules for operations and hardware designs had been laid down, it became obvious to Shea that there were still too many unresolved questions. He told the company to go back home and continue their studies. About this time, a small group in Houston took up the campaign for lunar orbit rendezvous. Charles W. Frick, who headed the newly formed Apollo Spacecraft Project Office at Manned Spacecraft Center, had aerospace management experience in both research and manufacturing, first at Ames Research Center for NASA and then with General Dynamics Convair for industry. Frick believed that Marshall, rather than headquarters, should be the target for an offensive. Frick said, quote, "It became apparent that the thing to do was to talk to Dr. von Braun in a technical sense, perhaps with a bit of showmanship, and try to convince him," end quote. During February 1962, Frick and his project office staff briefed Holmes on why they favored lunar rendezvous, but by Frick's own admission, they did a pretty poor job. So when Frick got back to Houston, he formed a small task force drawn from his own project people and Max Faget's engineering directorate to pull the information together. William Rector of Frick's office got busy on this more persuasive presentation. The result, a carefully staged affair that became known as, quote, Charlie Frick's Road Show, end quote. It consisted of briefings by half a dozen speakers. The opening performance was staged in Huntsville before von Braun and his subordinates on April 16, 1962. To emphasize the importance of the message, the Houston group included all of the top officials of the center, Gilruth, his top technical staff, and several astronauts, as well as senior Apollo officials from North American, the command module contractor. In a day-long presentation, Frick's troop explained 3 technical reasons for his center's conversion to lunar orbit rendezvous. First, it had the highest payload efficiency. Second, it was the smallest size for a landing module. And third, it required the least compromise on the design of the command module. The advantages of a separate lander, which would neither take off from nor land on the Earth, loomed large, since Gilruth and his men believed that landing on the moon would be the most difficult phase of Apollo, and they wanted the simplest landing possible. Frick and his road company next headed for Washington, where they gave 2 performances, for Holmes on May 3rd and for Siemens on May 31st. The Houston Center's drive to sell lunar rendezvous thus followed the path traveled by Hobart a year earlier. Although it doubtless reinforced his arguments, it appeared to have no other effect. In budgetary hearings before Congress in the spring of 1962, NASA officials named Earth orbit rendezvous as the best mode for Apollo, with direct flight as the backup. NASA Deputy Administrator Dryden said on April 16th, "As we see it at the moment, we're putting our bets on rendezvous with two advanced Saturns. However," Dryden continued, "if we find that we're not able to do this mission by rendezvous, we would be in a bad way." When asked by members of the House Subcommittee on Manned Spaceflight about approaches other than Earth rendezvous and direct flight, Holmes admitted that lunar rendezvous was also interesting. The mission could theoretically be performed with a single Saturn C5, but it was considered too hazardous since failure to rendezvous around the moon would doom the crew. Early in May, yet another scheme for landing men on the moon appeared. A study for a direct flight using a C5 and a two-man crew had been quietly considered at the Ames and Lewis Research Centers and at North American. Although there were objections from Houston, Shea hired the Space Technologies Laboratory to investigate the C5 direct mode. Other researchers at Ames spent a great deal of time on plans that revealed their dislike of lunar rendezvous. Alfred Eggers and Harold Hornby, in particular, traded information and mulled over rendezvous modes with North American engineers. Hornby favored a method that resembled von Braun's December 1958 idea, arguing the advantages of some sort of salvo rendezvous in Earth orbit. When he realized that NASA headquarters was on the brink of making the mode decision, Eggers kept urging Siemens to reopen the whole question of the safest, most economical way to reach the moon. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.